Hi, my name is Matthew Hostetler, and this is my presentation on classification and detection with convolutional neural networks. Our goal is to detect digits in an image like this one. We use convolutional neural networks to do it. We're going to use the Street View housing numbers dataset to train these networks, as well as patches taken out of these images which show not a digit. The first architecture we'll train is VGG, which was revolutionary because it had a very deep neural network architecture. In addition to training VGG from scratch, we'll try some transfer learning by pre-training it on ImageNet and reusing the base convolutional layers. We also try DenseNet, which is a cool architecture where early layers are connected directly to later layers. How'd they do? The VGG trained from scratch did okay. DenseNet trained from scratch did better, as expected. But the real winner was the VGG network pre-trained on ImageNet. It needed fewer epochs to get good results. It got the best final test accuracy and had the least drop-off between the training and validation and test accuracy, showing that it can probably generalize the best out of these models. So we chose that model for the rest of the system. To detect digits in an image, we used a sliding window and a Gaussian pyramid for scale and variance. The problem is this is a very large search area and we were getting a lot of false positives. By using the maximally stable extremal regions algorithm, we were able to detect blobs and objects in the image, which helped reduce the search area and the false positive rate. We also use non-maximum suppression. So before non-maximum suppression, we might identify many digits in an area when really there's just one. After non-maximum suppression, we take the box with the highest score and remove overlapping ones so that we only have a single box per digit. How'd we do? Here's a good example of us getting it right. Here's another example, this time in front of a brick wall. This time we're backlit and we get a good example. This time we correctly identify the digits, but we have some false positives. And finally, in the same image at the beginning of this presentation, we identify the digits, but we do have some false positives, particularly in the window. Here we can see the classifier presented on a video. As you can see, while we're moving the camera around, the system is pretty robust with respect to detecting the digits, even as we zoom in and out and change the angle. In conclusion, deep CNNs can be used to robustly detect digits in images. Transfer learning improves classification by CNNs. It's important to match training and testing data. In our case, we needed more negative images and more noisy negative images to decrease our false positive rate. Object detection algorithms like MSER can reduce the search space and improve results, and post-processing techniques like NMS can improve practical results without changing the model. Thank you.